Problem 1. Integral from 0 to pi over 2 sine cubed of x cosine cubed of x. And this problem can be solved in two ways by using trig identities. We could use cosine squared of x is equal to 1 minus sine squared of x, or we could say sine squared of x is equal to 1 minus cosine squared of x. Now, a good thing to do in these problems is think of your future plan for your u substitution. So I chose to use u as sine of x, du is cosine of x dx, which means I'm just going to save one of those cosines at the back, cosine of x dx, and turn everything else into sines so that I will have a power of sine a couple of times and du being cosine of x dx. So we take sine cubed of x, leave it alone, take cosine squared of x, change it into 1 minus sine squared of x, and then times cosine of x dx, which is being saved for your du. You need to do lots of careful algebra here. We're going to distribute the sine cubed of x into 1 minus sine squared of x to get sine cubed of x minus sine to the 5th power of x, still all of that being multiplied by cosine of x dx. Put this into two separate integrals. We have the integral of sine cubed of x cosine of x dx minus the integral of sine to the 5th power of x cosine of x dx. And finishing out, we're going to let u equal sine of x, du is equal to cosine of x dx, and we get the integral of u cubed du minus u to the 5th du, and we integrate the power rule, u to the 4th over 4 minus u to the 6th over 6, back sub to get sine to the 4th power of x over 4 minus sine to the 6th power of x over 6, plug in our 0 and pi over 2, get an answer of 1/12.